Hi guys, I apologize for the drop in sound quality, but unfortunately my microphone is broken. So, I'm about to record this video for the second time. Great, let's begin. So what we're doing is going over bad graphs here. Basically, what is a bad graph? It's things that don't convey information very well. I was about to say too well, I don't do English too well. So, let's begin with this one. So, Halloween candy collected. Well, we have a title, that's a good tick. And look at that, we've got an X and a y-axis. But what is the information that we're looking at? Well, Shayna and Michael and how much Halloween candy they've collected. First of all, we're told that it's Halloween candy. So why do we need to know with this image? It's irrelevant. I mean, it looks a little bit cool, but it is irrelevant, and it's, we're just trying to get information when we're dealing with graphs. The second thing is, it's like, okay, well, Shayna has 18 candies and Michael has 36 candies. Who cares? Why is there a graph for this? It is too simple for a graph. This information could just be represented in one line, as in like Shayna, blah blah blah, 16, blah blah blah, Michael, blah blah blah, 32, or 36 or whatever, 18 I think this was actually, right? And we'd have all the information we needed to. So this is far too simple for a graph. It does not need to be there. The second thing, well, where is our title? It does not exist. This is bad. The other thing is Bulgaria, apples, oranges, no, and 58%. Well, here's a word for you. Relevance. Is this information relevant together? What does 58% and Bulgaria and apples and no and oranges have to do together? Well, these are relatively relevant. Apples and oranges, they're both what? Fruit? Cool. Well, maybe apples grow in Bulgaria. Or maybe oranges grow in Bulgaria. Right. So, you can say it's like farming location. Farming in Bulgaria. But no. Well, preferences? 58%? What does this have to do with it? Is this the yes? And this is like maybe as well. It's the data here is completely irrelevant, and as such, it shouldn't be muddled together in this pie graph. Cool. So the next thing, well, look at this. We've got a title. That's nice, and we have an x-axis, but we don't have a value. Now I suspect that it would be dollar value. Actually US dollar value specifically. And this here is time. Again, we have an axis, but we do not have the values of the axes. So it's like, oh wow, look at this drop, $42.2 to 30, almost to almost 38, just a little bit below. And then oh wow, these are crazy. So this looks like quite a volatile situation for this Facebook IPO. It's like an immense drop here, and then it's, oh man, each of the things. But what you'll notice, and why it looks so volatile, is because this is not a zero axis. So we had a zero axis here, and we don't have an axis in a pie chart, so it doesn't really matter. But a zero axis would represent this information better. So what I'm going to do is quickly draw a graph. Now I know that it's not going to contain things like a title and an x and a y axis. I just want to show you what's happening. So we're going to say that this here is 42. We're going to say that this here is, say that this is 42. We're going to say that this is 0, and we'll say, what's it, 30, so we'll say 42, so what's that? We'll divide that by 7. So 2, 3, 4, 5, 6, 1, 2. So what's that? Divide 7, so 6, 12, 18, 24, what's this, 30, 36. Well, okay, so we start at what, 42.2, and then we drop down all the way to 38, and blah, 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 blah. Pretty much does that, right? In fact, actually this is too low. It's more like this. So the problem here is that the proportion looks significant. This is a humongous drop, but this is what the drop actually looks like. So in the way that you viewed it, because of the way that they haven't put the zero axis in, you are distorted to thinking that this is a much larger change than it is. And what this will do is, if you're looking at this, you'll over-represent the value change that has occurred. Now, a computer wouldn't fall for this because a computer would just see the data, but a human would, because the human eye is like, oh, just looking for patterns in the thing, and the pattern would be a humongous downward trend. Now let's continue on. So, what I've got here is a pie graph with no title. Bad. But the other thing is, well, alpha, beta, gamma, epsilon, theta. So these here are probably what, Greek symbols? Maybe they're particles. I don't think there are this many particles. But, you know, there's like an alpha, beta, gamma, delta, epsilon particle. What does this information really tell you? Well, nothing. Why? Because it is, and it's the exact opposite of this, if you want to complete my sentence, it's too complex. So the information here, it's trying to show too much information. So what you want to do is, when you have a very complex set of data that you want to combine together, what you might do is say that you're going to take values. We'll say that this here is the largest value, and that these are. So this here is the largest value, and that as you go around, the values become smaller. So let's say that you want to say 80 is the smallest value. So what you would do is then take all of this data, all of these, 74 through to whatever 38 I think it is the last one, and we call it other. And what it does is takes all your small data, groups it together, and summarizes it to make it very clear what it is that you're after. Because you're looking for you're looking for what is the prevalence of alpha versus beta versus gamma versus, and stuff like that. And then you have other for this. So all of these, is it from tau? No, from all of these ones suddenly become represented by other. And as such, your data is summarized. Now, the last thing, we're dealing with a pictograph here. Well, good. Look at that. It has a title. Pictographs don't really need axes. So what we're looking at here is the change. It's gone from $1 to 70 cents to 56 cents to 50 cents to 46 cents. So you would say that the change has gone from $1 to 46 cents, right? That's the overall what it's trying to represent. Oops, 46. Now, here's the important thing, and this is the same issue that we had up here with the zero axes. Is this 46% the size of this? Well, no, it isn't. This here is much smaller than 46%. I believe that what they've done is taken the diameter, and that the diameter is 46% the size of the diameter here. But that is not an accurate representation. If this here is much smaller than 46% of this. This is probably more like 20. And so you over-represent. You're like, wow, my dollar value has gone down by so much. Look how small the coin is over time. But really, it should be something like this. So, oh man, I'm just doing well, I haven't measured it out. But basically, the coin should be much larger proportional to this, because this is about this size on there. And that is not 46% the size of that Canadian dollar. And it over-represents the decrease in purchasing power which this graph is trying to get across.